And here we are with solving equations. For solving equations, if you've been working with factoring, this is where factoring will actually come in handy. So let's say we already have something that's been factored. Let's say we have, ooh, wrong marker. Let's say we have x times x plus 1 is equal to 0. Whenever you're solving equations, quadratic equations, which means it has some sort of an x squared value, if we were to distribute this x, we'd end up with an x squared plus x. But what we really want to do is know for what values of x make this equation true. And that's easy to do when we use the zero product property rule. If you remember zero product property, it's pretty much if you have any number, let's say a times 0 is equal to 0. So if we multiply something by 0, automatically it's equal to 0. So this means that x is multiplying what's in parentheses x plus 1. So these are two factors. X is one factor and x plus 1 is another factor. And if either of those is equal to 0, that makes this whole equation equal to 0. So all we have to do is set them apart. So this is one factor x. We set x equal to 0. So 0 is one of the values that will make this equation true. And we set our other factor equal to 0, x plus 1. X plus 1 equal to 0. We subtract 1 from both sides. And we get x equal to negative 1. So if x is equal to 0 or if x is equal to negative 1, that makes this equation true. Those are the values of x that make it true. Those are our solutions. So let's try another one, maybe one that's not factored already. So let's say we have x squared minus 8x is equal to 0. Well, how do we figure out what the answer should be? For what values of x is going to make this equation true? Well, first let's factor it out and separate it into two products, because right now what we have are two terms which aren't being multiplied at all. So what we want to do is turn it into two products. So here we can factor out an x from both terms. So if we have x times x minus 8, that gives us an equivalent equation to what's up here, and then we just set the different factors equal to 0. So here we have x as a factor, x equal to 0. That makes the equation true. And then we have our other factor, x minus 8 equal to 0. We add 8 to both sides. X must be equal to 8. So those are our two values which will make these equations true when x is equal to 0 and x is equal to 8. So let's say we have x squared plus 3x plus 2. So we need to factor this in order to solve for what values of x is equal to 0. So first we look at the back. We see that this is 2. The only factors to make 2 would be 2 and 1. The only factors to make an x squared would be x and x. We look at the last term, the sign. That is positive, so that means same sign. Same sign. That's what the positive indicates. And if we look towards the middle, we know that the signs have to be positive. So here we will have an x plus 2 and an x plus 1 equal to 0. So now we have two factors. We have x plus 2 multiplying x plus 1. So let's set those factors equal to 0. X plus 2 is equal to 0. You subtract 2 from both sides. X is equal to negative 2. Then we have x plus 1. We set that equal to 0. Subtract 1 from both sides, and x is equal to negative 1. So those are the two values of x that make this equation true. So we have time for one more, final one. So let's say we have something like 3x squared equals negative 14x plus 5. Now, there's no 0 in this equation. However, we can move the terms so that one side of the equation is equal to 0 and all the other terms on the other side. So let's do that. Let's add 14x to both sides, plus 14x. We get 3x squared plus 14x is equal to 5. And now let's subtract 5 from both sides. So we subtract 5 from here, subtract 5 from here. 5 looks a little weak. And we have 3x squared plus 14x minus 5 is equal to 0. Now we have an equation that can be solved. Scoot that up. So let's work here and let's figure out what values are going to work. We have 5. The only factors that will give us a 5 is prime, which would be 5 and 1. And then we look at the front and we see that the only thing that can make a 3x squared would be a 3x and an x. And we see that the signs have to be opposite because there's a negative sign. So you have to multiply opposite signs. And then our middle term is a positive 14. So when we actually try to solve, we want to make sure that we get a positive 14 left over. So let's bring out the other board. See if we can get this done. So we had 3x and x, and we had 5 and 1, and we know that the signs have to be opposite. So if I do 3x times 1, I get a negative 3x, so it's 3x times negative 1. And if I do x times 5, I get plus 5x. Well, that's not equal to 14x, a positive 14x, so we have to try again. So let's erase this, and let's switch the numbers. We'll keep it positive, negative. Let's put the 1 here and the 5 here. So we have x times 1, a positive 1, is equal to an x, and 3x times negative 5 is equal to a negative 15x. Well, that equals a negative 14x. So that's not quite what we need. What we need to do now is switch the signs. So we'll make the top one negative, the bottom one positive, and that will give us a positive 15x, a negative 1, which gives us a positive 14x. Now we have the pairs that we need for the factors. Our first factor will be 3x minus 1. Our second factor will be x plus 5. Let's write that out. 3x minus 1 times x plus 5 is equal to 0. Now we're ready to find a solution. So again, we take each factor and we set it equal to 0. So we have this factor, which is 3x minus 1 equal to 0. We add 1 to both sides. We get 3x is equal to 1. And then we divide by 3. So one value that works is when x is equal to 1/3. Now let's try the other factor. Our other factor here is x plus 5. So we set x plus 5 equal to 0. Subtract 5 from both sides. And we have x is equal to negative 5. So that is our second solution. And x is equal to 1/3 is our other solution. Those are the two solutions to our original equation, which was down here, 3x squared equal to negative 14x plus 5. So we set the equation equal to 0 by moving the terms, and then we found the different factors. We set each factor equal to 0, and we solve for x. That's it in a nutshell.